So to calculate the speed, we have distance in kilometers and time in minutes. So as you can see here, to calculate the speed of these motions, we should find the gradient of this function. So as you can see here, we have 8 kilometers. If you convert this to meters, it's 8,000 meters. And we have 6 minutes. We should convert this to seconds also. So it will be 360 seconds. If we find the gradient, it's 8,000 over 360. It's 22.2 meters per second. So as you can see here, it's first calculating the rise and then run. So it converting to the meters and then seconds, and answer is in meters per seconds and 22.2. So work with example. Next one. Oz decides to take a stroll to the park. He finds a bench in a quiet spot and takes a seat, picking up where he left off reading his book on black holes. After reading some time, Oz realizes that he lost track of time and runs home. Distance time graph for his trip is drawn below. You can see here A, B, C parts of his motion. So how long Oz spent reading his book? So as I mentioned before, if the line in distance time graph is parallel line to y axis, that means that the object didn't move. So that means we have only B part where Oz didn't run. So we can assume that he was reading book. So for the first part of the question, answer will be how long does Oz spend reading books? So we can see here from 25 to 65. It's 65 minus 25 and it's 40. So as you can see here. And B question, there are 3 sections labeled on the graph A, B and C. Which section represents Oz running home? So as we said before, the steeper the line, the higher the speed it has. So in the question it's asking in which section he was running. So that means when he was running, his speed was higher than he was walking. So we can draw here to explain you. If line is like this, that means the object has higher speed than this. So as we can see, the C part is the only steepest one. So for the B1, the answer will be C. The section C. So what is the total distance traveled by Oz? So total distance traveled by Oz is just simply 0.6 kilometers. As you can see here, it's he's starting from 0 and coming to 0.6. So moral of this topic is that to find distance, you should just look at the y-axis. So speed time graphs. Speed time graph is also similar to distance time graph, but in speed time graph, time is in x-axis and speed is in y-axis. So a speed time graph shows how the speed of moving object varies with time. So red line represents increasing speed, that means acceleration, and the green line represents deceleration. So increasing and decreasing speed represented on this speed time graph. So acceleration of on a speed time graph. A speed time graph also show the following information: if the object moving constant acceleration or constant deceleration. So as we can see here, if a line is like this, that means that that doesn't mean that object is not moving. So this means just the speed of the object is same over time. So object was always with same speed, but if it's in the x-axis, that means that his speed was from 0 in the beginning of the journey, and in the end of the journey it was 0. So but for example, if we draw a line in this speed time graph, if it's going up, that means the speed is increasing, and if it's going down, the speed will be decreasing. So the magnitude of acceleration or deceleration is can be calculated by speed time graph, as we saw in the speed distance time graph. We calculated speed using finding the gradient of the distance time graph, and in this speed time graph, to calculate the acceleration, we should find the gradient of the line. So for example, in this situation, we have this line, and time here is approximately 8, and the speed is approximately 7. So acceleration will be 7 over 8. So it's 0.875. Straight line represents constant acceleration. So this straight line represents constant acceleration. The slope of the line represents magnitude, and if we calculate this area here, for example, for red line, if we calculate this area here, this is v times t, and this is will be the distance traveled by the object. So speed in this graph, the speed will be 0 at first, and object will be at rest, and in the second part, the object is accelerating. As you can see, it's upward sloping, and if it's not in the x-axis, and it's a linear line, and that means the object has constant speed during this time, and in the last part, it has constant acceleration, as it is upward downward sloping and has flat line. So using speed time graphs, distance traveled by an object can be found by determining area beneath the graph. So as you can see here, the area of this shape is also known as distance, because we are calculating velocity by time. We can use the mathematical formulas to calculate this distance. So worked example 1. The speed time graph below shows a journey, car journey which lasts for 160 seconds. Calculate the total distance traveled by on this journey. So to find the total distance, we should find area of this graph of this shape is area 1, area 2, area 3, and area 4. We had to estimate this, and to calculate the first part, we used formula of the calculating the triangle. So it's 40 times 17.5 times divided by 2, and for this part 30 times 17.5, and for the third part 20 times 7.5 divided by 2. But for the fourth part, it's 20 times 17.5, and for the last part, it's 7